we're going to go back a little bit and forward a little bit with the idea about factoring and solving. You already have some foundational factoring that you've done, and most of you, if not all of you, are really competent in solving. You do a really good job at solving equations, and most of you are pretty solid with your factoring. Again, it's not going to go away. If you aren't solid with the factoring, I don't know what to do. Come in. I will help you. Print out the review, bring it to me, and I will help you try to get that thing down. Now, what we're going to do is we're going to look at some old stuff, but we're also going to go on to sum and difference of the cubes. We're going to talk about factor by grouping and what it means to be in a quadratic form even though it's not a quadratic. So we're going to look at those along with some of the review stuff. So you'll see, like, whenever you see this kind of thing, this comes right out of your book, so you probably see these things somewhere in your book. Now, this is just a regular trinomial, right? 2x squared minus 3x minus 20. Hopefully, every single one of you can factor that. 2x plus 5. Okay, 2x plus 5 and x minus 4. Some of you use a box method. Some of you have the little x. Some of you make a diamond. Okay, some of you do borrowing from the clouds. Some of you do a guess and check. I don't care. What I care about is that you can look at this and say, that's a perfect square trinomial, and that you can factor it to x plus 4 squared. And when you see a difference of two squares, that you can factor it instantly to 3x plus 1, 3x minus 1. And when you have a common factor, you can take the common factor of 4x out, and you're left with 2x plus 5 and the 4x outside. Those are all review. Only half of you can identify these perfect square trinomials. So you should go online, look at the factor review, go to the GBHS Math Shorts, look at the 5-minute video on it. But you need to know how to do perfect square trinomials. Step number 1, take out what's in common. Step number 2, difference of the squares. Step number 3, PSTs. Step number 4, factorable trinomials. Then we're going to add today a sum of the difference of the cubes. And I'm going to use a different slide to do those momentarily. This is the one that sometimes we get excited about another step and we forget to take out what's in common. So if you look at this example, what's in common? X. So you want to pull that x out, you're left with x squared minus 4x minus 12. Then you can proceed to another factoring step. Those of you who borrow from the clouds, if you don't factor out what's in common, especially if it's a constant that's in common, the borrowing from the clouds process on the trinomials won't work. I'm not sure if everybody who does that is aware of that. It's just a gimmick. It's just a method for factoring. X squared minus 4x minus 12, how does that factor? X plus 2x minus 6 or x minus 6x plus 2. I don't care which order they're in, as long as the 6 is the negative and the 2 is the positive. This is a complete factorization for us. That's what I'm looking for. This is what I'm trying to stress right here because it's so often ignored. You've got to check for that what's in common first. See if you can do B. What's in common, factor it out, and then see if you can do. For the B, what was in common? 3x, leaving you with an x squared plus 10x plus 25. We need to start recognizing that as a PST. If you're factoring it into x plus 5 times x plus 5, that works, but it's slowing you down. You need to recognize that this is x plus 5 quantity squared. I would want to really have you recognize some PSTs. What's in common? 5g to the third. Leaving you with g squared minus 16. Bless you. If you only pull out a g or a g squared, then this is still going to have more g's that are in common. You got to keep pulling them out. And then g squared minus 16.
Plus 4g minus 1.
Those are g's, not 6's. Okay? So what's in common? Got to get it out first. You might remember difference of the squares. And I know we're reviewing stuff you're supposed to know, but there are still people in the room that can't factor the first 4 steps. You need to get help. Okay? You've got to get help. Come and see me. Difference of 2 squares, a squared minus b squared. Always factors to a plus b, a minus b. A lot of that conjugate stuff going on there. So first squared minus second squared. This first plus second comes first minus second. And you want to make sure, again, as soon as you recognize what it is, that you can factor it. Now, these are the notes that are part of the factoring review on PSTs. There's a couple of ways to tell if you have a PST, and one of them is, if you're in standard form, half of b squared is equal to a times c. Sometimes, though, that gets to be kind of big, especially if a and c are larger numbers, and especially if I keep telling you, don't use your calculator for this stuff. So the other way to do it is to look at the radical, the square root of a and the square root of c, and multiply those together, and that should be equal to half of b. Easy, this yellow one is the easiest way to go. Take the square root of a times the square root of c, and as long as you get half of b, you're good to go. And then the factoring is really easy if you get a yes. Square root of ax squared, that's the first term. Whatever the first sign is goes in between, and whatever c is, take the square root of that, wrap it, and square it. Again, these notes are part of the factoring review. It's the very first file available to you in Chapter 1. But a PST generates a binomial square. So we want to make sure we're pretty well versed in those factoring processes. If you're not, and you feel like it's a weakness, come and get help. How you decide to factor your trinomials, again, I honestly, I just don't care. You can Harry Potter them for all I care. Yeah, no kidding. Oh, you want really cool, and we'll try to have this pretty soon. I'll show it to you. Texas Instrument. Now, here's the 2 new ones, and they are literally patterns. When you can identify that you have something to the 3rd power, something cubed plus something cubed, it's going to follow a pattern. And it's a lot like a difference of 2 squares, it's just a little bit of a longer pattern. Remember your perfect cubes. We talked about these, and I said, look, you really want to make sure you memorize your perfect cubes. Here's the first 7. 1, 8, 27, 64, 125, 216, and 343. You want to recognize them on sight. If you ever see them out on the street, you want to go, oh yeah, 343, I know you. You're 7 cubed. You want to be able to recognize them on sight. So if you feel like that's a weakness for you, on a quiz or a test, the first thing you want to do is just work them out. 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, 7 cube. Write them right on your paper. It'll help. It's better than nothing. You obviously haven't done what I asked you and memorized them, but write them down. At least you'll recognize them. Now here's the pattern. And you'll see, I'll show you this just real quick. Here's 6. This is a difference of the cubes. It's almost identical. Almost identical. So how do we keep them straight? Well, you just need to have some sort of a gimmick. And the way that I remember this, when you factor a sum of the cubes, you're going to get a binomial times a trinomial. In both cases, sum and difference. The binomial gets the same sign as the trinomial. So excuse me, as the original sum or difference of the cubes. If it's a sum of the cubes, the binomial is a sum. And it's a plus b, and then it's a squared. If you put a plus here, switch the sign in the first one here. So it goes plus minus, and then this is always going to be plus. Now, what does a squared minus ab plus b squared look kind of like? It looks almost like a perfect square trinomial. If this were a 2, you'd be there. So you just have to remember that it's not the perfect square trinomial. It's not what you get when you square a plus b, but it's really close. It's a squared minus a times b plus b squared. This trinomial, despite some of your extreme efforts, will never be factorable. So when you have a sum or a difference of the cubes, it's one-step factoring. And I'll give you some examples with this in a minute, because it's harder to see in general right now. If I switch this to a minus, what's going to switch down here? The first sign becomes a negative, and then a positive. So it's plus, plus, minus, plus, minus, minus, plus, and plus. And that, come up with whatever you want. If this is a minus, the binomial is a minus, and then these are going to be opposite signs right here. Everything else is the same.
And b squared is always a plus on the...
There's no way for it not to be.
Okay.
Think about how we're getting it. We're taking something and squaring it.
And you can't...
Can't be a negative. This is a negative here. When you square it, it becomes a positive.
Yeah.
That's the easiest way to think about it. There's no way the last term could be negative.
Is that one also never factored?
Yeah, good. Thank you. So this trinomial, no matter what, the trinomials, when you're factoring sum and difference of the cubes, are never factorable. There's no way. That's why sum and difference of the cubes, one-shot factor. But you got to learn the patterns. You got to memorize it. Almost all of you are going to do that. And almost all of you are going to do it tonight. Don't be one of those 3 or 4 who doesn't do it. You got to get it down. Let's look at some examples. Well, let me give it to you. Here's a different way to notate them both at the same time. All the signs on the top go together. So if you want to write the both rules in one shot, you have a cubed plus or minus b cubed. If it's plus, it's going to go plus, minus, plus. And if it's minus, it's going to go bottom sides, minus, plus, plus. They're just both of them put together. You see them like this in some books. I don't know if our book does it that way. But that's just another way to write sum and difference of cubes. Okay, if you want to have a more compact thing. I would want them on different note cards if I was studying them. And again, I want you to make the connection that whatever sign's here also appears in the binomial. The hard part is that A could be something like an expression like 2x. Right? You have to identify it, just like with difference of the squares, you have to identify them as one thing being cubed plus or minus a second thing being cubed. Now for me, I'm going to write them that way for now, but you don't have to show this right here. X is being cubed. What else? 5. So if you want to rewrite it so that you can see first thing cubed plus second thing cubed, that's great. Is there a problem? You're stuck on squares? Is somebody stuck? You got to be thinking cubes, not perfect squares. So the cube root of 1.5 is 5. So it's first plus second, first squared, minus first times second, plus second squared. So we're using this pattern right here, a cubed plus b cubed. X is the first thing, 5 is the second thing. X plus 5, first thing squared, first times second, second thing squared. Well, factoring introduces parentheses. That's what factoring is all about. Factoring takes a plus or minus problem and turns it into a multiplication problem. Is that what you're asking me?
I'm saying I was trying to get rid of it.
That would be if I asked you to simplify, and this would be already simplified. My directions now, what we're doing here is we're factoring. So the directions right now are to factor. And this is a sum of the cubes, so it's part of our new factoring process. Let's, y cubed minus 8. What's the first thing being cubed?
Why?
And the second thing? And again, I'm not telling you you need to do this line. If it helps you to do this line, have at it. On these problems like this, you're going to stop doing this very quickly.
2 cubed not squared.
Thank you. So this is going to be y minus 2. First thing squared plus 2y. Never minus, always plus on the last one. Now again, remember this is not twice the product, it's just the product of these two.
So why would they say 5 divided by 2?
It doesn't. This is what we're doing right here. We're in step 5. This is step 1. Take out what's in common. There isn't anything. There isn't a difference of the squares. It's not a PSP. It's not even a trinomial. So it's not a factorable trinomial. So is there a sum or a difference of the cubes? You bet there's a difference. This is step 6. We haven't talked about that. Step 7, we haven't talked about that. Okay, so right now, we're only looking at sums and difference of the cubes. This pattern, it just takes time. It takes practice. Here's where it starts to show a little bit trickier. So when we look at this one, and I say, look, we need to recognize that it's something cubed minus something cubed. This is where it may be beneficial for you to say, all right, let's write it as something cubed. What is the first thing that's being cubed? And the answer to that question is not 4. 4n needs to be one monomial to the third power to get this. And this one is 3. And believe me, they're going to keep you by and large at 343 or less, so 1 through 7 cubed, unless they want to mess with you. So it's 4n minus 3. Careful now, what goes here?
16n squared. Plus
12n. If you ever get stuck as to what goes in that middle spot, just take your binomial and multiply them together. 3 times 4n, 12n. Just make sure you have the right sign. And then take the last term and square it. Close enough. Don't start thinking, oh yeah, but this one's going to, oh, it's a perfect square trinomial, 4n plus 3 squared. It's not. It's never going to be a perfect square trinomial. It's kind of looking like it, but the square root of 16 is 4, the square root of 9 is 3, and 3 times 4 is 12. That's not half of 12. So it's never going to be factorable. So don't fall for that trick. Okay? What do we do? I didn't say you could. I don't want to know what I can't do. I want to know what I can do. You've got to factor out what's in common. Remember I said, if you don't do the GCF, and we get so entrenched in, hey, that's a cube, it's got to be a sum of the cubes. It's not. Because it's not a perfect cube here or here. So the first thing you've got to do is pull that 2 out, and then you got a sum of the cubes. So see if you can finish that one off. And people will say, how does the w cubed plus 27 factor w plus 3 and w squared
plus.
And a lot of times that will be the final answer that I get.
And then go yes for the two.
But you have to remember that this 2 is still part of our factorization and needs to be included. Do you guys all shop at the same store, or what's the deal with all the vests?
Actually, this is for work.
Huh?
I just took it.
Where do you work?
My dad.
You work for your dad? And you're the guy with the flag? Or the stop sign, or do you pick up trash?
It's not a data bag.
You're on the track? That means you wear that because you're a target, huh? Alright, so everyone follow why the 2 has to be part of our answer? Don't throw out the 2, that's the easiest thing to do. This 3, this is 3 cubed. So this is about the time where I'm going to stop doing it, but
Okay.
you're welcome always to rewrite, if that helps you. And especially in this first couple days, that might be the way to go. But you'll get tired of doing it as soon as once it clicks, it's going to click hard and you won't have any problem remembering that. Alright, so we have these steps of factoring. We have what's in common, difference of the squares, PSTs, factorable trinomials, and then we have sum and difference of the cubes. How about this one right here? You look at this problem right here. How are we going to factor that?
By grouping.
Well, what do we do first? And what's the greatest common factor?
Nothing.
Look at them all. Yeah, when there's a 1, there's always a 1, but don't give me that crap. Yeah, me either. There's nothing in common. What's that? Is it any of our other things? Why not? Because that's the best answer you could have given. It can't be a difference of 2 squares because there's 4. It can't be anything trinomially because there's 4. And it can't be a sum or difference of the cubes because there's 4. Yeah.
So do you split it?
Well, at this point, you don't know what to do because we're a few minutes away from, not even a few minutes, we're very close to me telling you, but we aren't really there.
Can I make a guess?
Well, the process is called grouping. In grouping, you put them in groups. You put them in groups. You split them maybe. Now, in Algebra 1, this is the honest to God truth. In Algebra 1, 20 years ago, we taught factor by grouping. And it was pretty straightforward what we're going to do right now. And in Algebra 2, we had nasty grouping. They're not doing it. They're very, very nice to you in here. Here's my promise to you. 4 terms. I guarantee you're going to group first 2 and last 2 every time. You're going to put parentheses around the first 2 and the last 2 every single time. I'm going to take those out for a second.
So that you can 27.
If you see a minus right here, if your third term is negative, if the third term is negative, right? This is really important, and this will always be true. If the third term is negative, you must factor a negative from the second group. Really important that we keep that in mind. Third term is negative. You're going to always factor, hang on to your question for 1 minute. You're always going to factor out a negative. So when I group these, I'm going to group the first 2 terms and the last 2 terms. And then we're going to go back to what's in common. In the first parentheses, what's common in there?
3t.
T squared.
9t.
9
T squared.
t in to the power 2 for the c.
Alright,
What's left in the parentheses if you pull those out? 3t plus 5. Oh my gosh! There's a negative here. Is there anything else in common?
No.
There's really nothing in common, but I'm telling you, if the third term is negative, no matter what, you have to pull a negative out. If you're only taking the negative, put a 1 with it. It'll help you in a minute. And when you take that negative 1 out, now these two binomials, right here and right here, are the same. If they are not the same, one of two things has to be true. Either it's not factorable, or you're making a mistake. Very good. So if you screwed it up and you know that it is factorable, then these two have to be identical. When you take 3t plus 5 and we take that common factor out, 3t plus 5, you're going to be left with 9t squared and minus 1. The common factor here is the 3t plus 5. When we take the yellow factors out, you're left with the 9t squared minus 1.
3t plus 5 squared.
Nope. You're taking out a common factor, just like when you took 9t squared out of this first parenthesis, you didn't put 81t to the fourth, because when you multiply this back in, you get this, right? If I multiply this purple parenthesis times 9t squared, I get this.
Yeah.
And when I multiply it by minus 1, I get that. All right?
that second, the third term, if that was a positive,
With, like,
instead of minus.
here,
Yeah.
then this would not be factorable. Because your binomials would not be, you would factor out a plus 1 instead of a minus 1. And then this and this would be different. Now, some of you are getting ready to do the touchdown dance on this, but my A students know better.
Squares.
Difference of two squares, that's right. 9t squared minus 1, 3t plus 5, that's going to be 3t plus 1, and 3t minus 1. The superstars don't get fooled by that kind of a trick. You get so excited you did factor by grouping that you stop your work? No way. I am waiting. Be waiting. Someone said wait. It's you. Everybody clear on this? This factor by grouping stuff. It's new. How do you know when to factor by grouping? Got to have 4 terms. Got to have 4 terms. So this one, we group 4 terms. We group first 2. We group last 2. What's in common in the first one?
R squared.
R squared. Who's left?
R minus.
What's in common here? 6. So we're going to get plus 6. R minus 3. Look at that. They're the same again. Wow. And my promise to you in this class is that it's always first 2, last 2. We used to mix them up. You used to have to regroup them into all different types of patterns. We used to do 5 and 6 terms, so you'd have to find trinomials that work. Ugh. It was nasty. This is way easier. What do I do to factor it? R minus 3 comes to the front. Can we factor the R squared plus 6?
No.
We're done. We're seeing it? Try this one. Group them, first two and last two. What's in common here? Who's left?
X plus
What's common?
6.
X plus 6. The x plus 6 is matched. That's what we hope for. Pull that to the front. And then who's left? Excellent. What's that? Well, why would you not want to put it in the front? Let's go back to this and see what you do on this. Here we are. How come you didn't put this x over here? Because you're factoring out what's in common, it makes more sense to put it to the front. And then what's left, so that we redistribute this. So I'm using that same exact process. This is what I want to do next. And I'm using that same exact philosophy. What's in common, move what's in common to the front, and who's left out here. 9 out of 10 times, this is not going to be factorable, the x plus 6. Sometimes this is factorable. But what's in common typically is not. Is it going to be marked wrong? No. And it's, I would just say maintain consistency. But if you put what's in common before in the front, you should be doing it in the front now. Let's look at number 10. Let's see what this says. Same stuff. Now, number 10, the third term is negative. So when you put the grouping, the negative needs to stay inside with that 16z. And I don't mean this to be, oh, you're multiplying now. We're not. We're really adding these two parentheses together. But you need to be careful when you're factoring the second group, because you have to make sure not only do you take out what's in common, but it also needs to pull the negative. Right here. And it never occurred to you to continue on with the z plus 4, z minus 4. Okay? I know some of you did, and I know some of you are going to do it all through this chapter. You have to put some kind of a reminder to yourself. Always check to see if either of the parentheses can be factored further. Every once in a while, you can do it. So this is where we end, right here. What? This problem. Is this a quadratic? How do you know? It's not what? It's not x squared is the highest power. Highest power here is 4. A lot of ways for you to handle how to do this. I'm going to show you 2. Okay, I'm going to show you 2 different ways to handle it. Some teachers and some students like this method. Take a variable that's not in your problem. I'm going to use z for this one. And let it equal to whatever half the power is of the largest exponent. So if this is x to the 4th, we want to let z equal x to the 2nd. If you had an x to the 10th, you would let z equal x to the 5th. If you had an x to the 12th, you'd let z equal x to the 6th. It's got to be an even in order to be in quadratic form. Then we're going to replace x squared with z. 10x to the 4th would become 10z to the 2nd minus 10.
Oh, yeah.
Z squared means x squared squared, x to the 4th. Right? What's in common? If you pull the 10, you get z squared minus 1. How does z squared minus 1 factor? Again, don't want to do the touchdown dance, even though we're done factoring, so we think. What do I need to go back and do?
With extra one.
Yeah, go back and make these x's, so it's really going to be 10 x squared plus 1. We're still good, we don't need any more factoring. But here you get x squared minus 1. And when that happens, what do we need to do?
Another square.
Another what?
Make another difference of 2 squares.
Another difference of 2 squares. So our final answer and again, please don't misconstrue. I'm not selling you plug in z for x squared. I'm just saying that's one method that works. And it works great. Okay. Yeah.
How to get the final answer, how to give it the x squared.
This x squared?
Yeah.
It's written right here.
So you bring.
What is z equal to?
Okay. It's x squared.
So I just replaced the x squared back into z, here and here.
Yeah.
But this one's factorable.
Okay.
This one's not.
Okay.
Good on that or no? Okay. So we'll show you another way to handle this one. 3m to the 12, 54m to the 7, 51m to the second is not a quadratic, and it's not in quadratic form. Okay? In order to be in quadratic form, you have to have the biggest power. If this is a trinomial, the middle power has to be half the biggest, and it's not. What can we do to this problem? What can we do?
Take out 3.
You can take out a 3. What else can I do?
Oh, and m squared.
And an m squared. And if you do that, you'll be left with m to the, careful now,
6.
nope,
No, 10.
10. Plus 27? I don't think so.
No, sorry.
17 makes
2.
18,
18 probably.
m to the 5th, plus
17. 17.
17 nothings. Now, again, in this problem, you are more than welcome to recognize that you could let z equal m to the 5th. Because this is 10 and this is half a 10, this is going to be in quadratic form. Okay? But without putting the z's in, we can just treat it the same way as we would if it were a quadratic. And we factor by box method, diamond method, borrowing from the clouds, whatever. 1 times 17 is 17. Factors of 17 that add up to 18, this one's easy. 17 and 1. Both of them are going to be positive. So the 3m squared is part of our answer. Since this is m to the 10th, we cut it in half. We use the one in the middle, m to the 5th, m to the 5th, and we don't need any coefficients on them because this is a 1. And then it's plus 1 plus 17. We're done.
What's going to work?
What if the leading degrees?
Then you would factor it the same way. Then it doesn't work. It has to be, this has to be half of this. Middle power has to be half of this power. If it's not in quadratic form. If that's a 9 and this is a 4, you're not.
Then you say that one.
Well, we got a 3m squared out.
Say no, like 7 come out of it and the middle.
Yeah, it wouldn't be fact. I would just leave it. Now, how about this one? If we don't go by the z method, this is also a difference of 2 squares. What's the first thing being squared? X squared. And the second thing? 6. How's it factored? X job. Can we go further?
Do you have to put a 6 squared? Or
Yeah, this line you don't need at all, but if you do, it's in the 6 squared, yeah. Can I factor further? What can I factor further? Both of them, or one of them, or?
yeah,
X squared plus 6? How's it factor? You're messing with me. Are you doing the thing where you... What's the matter? Are you grumpy today? You get enough sleep last night? Your sweetheart keeping you awake or what? What's going on? Worried about the bonfire tonight? What do you? I thought you weren't coming to class today, there, bonfire girl.
Yeah, I think it's fine.
But you said you were gonna miss anyway.
I shouldn't miss you.
Huh?
Like when you try like bargaining with someone and then you like walk away and then they're like, okay, you can miss class, but you didn't do it. So.
This is what you do with your dad, huh? What about you? Well, back to you. Is everything okay? Anything you want to talk about?
I'll go
In front of the whole class, right? Yeah, well, if we need, let me pause this. I need to finish up.
We should have had that recorded.
Yeah, right.
That's great.
The ones that you're going to have most trouble with tonight are the ones that are in quadratic form. So either replace with z's or just recognize, look, if this power is half of this, it's going to factor to x squared plus 5 and x squared minus 4. Doesn't matter which order you put them as long as the 5 is the plus, the 4 is minus. And then don't go right to touchdown dance. Then what? X plus 2x minus 2. Well, a lot of people cannot visualize that process. If they say let z equal x squared, and you write down z squared plus z minus 20, they go, oh yeah, that factors. I can do that. But there are people who just struggle when this is not a square. And they're not recognizing it as being in that same form, just with a different main variable with a power. So I don't care which way you do it. If you use the z's, just make sure you replace them at the end. So if you have something like this, again, some people will panic, but 6 times negative 4 is negative 24. Factors of 24 that subtract to 5.
8 and 3.
8 and 3. Who's positive, who's negative?
Negative 3, positive 8.
Negative 8, positive 3.
You're going to say.
You said the other way around. So it'll be 6y to the 6th minus 8 and 8y cubed and 6y to the 6th. Minus 6.
We have to take half of that.
Plus 3y cubed. So what's in common in the first binomial? 2y to the third. That's going to leave you with 3y to the third minus 4. And what's in common here? 3y to the third. And that's going to leave you with 2y to the third plus 1. These we throw away because that's factor by grouping. I don't care how you factor your trinomials. But if you do borrowing from the clouds and you get to this grouping stage, what you factor out, you throw away. If you multiply this times this, you get 6y to the 6th. Negative 4 times 1 is negative 4. Negative 8y cubed plus 3y cubed is negative 5y cubed. And honestly, the method doesn't matter to me. That's the truth. I don't care what method you use, but I care that you have a method, whatever that is.
Are all the ones that are in the homework, are they going to be where it's like 6, 6, 8?
If it's not even and then half of that even number, just leave it. You can't factor it. But be careful, sometimes you have to take out what's in common first.
Okay.
And then if it's not in that form, you're done, and there's nothing wrong with being done. Yeah. I told you, there's a bazillion answers. Now, the other part of today's work is why we learned factoring. Why you spent all this time in Algebra 1. Why we've reviewed in Algebra 2 at the beginning of the course, and it keeps coming back. The reason why is so you can solve equations. Now, right now, we really want to be real number solutions. We're not looking at imaginaries. One of your sides has to be a 0. The side that should get the 0 is the side that will allow the highest power on the variable to get a positive coefficient. So identify where is the term with the highest power, and then make sure that it has a positive coefficient and bring everybody to that side. So 2x to the 5th minus 12x cubed minus 16x is equal to 0.
Plus 16x.
Sorry, thank you.
Why 2 already?
Because that's the term that has the highest power. So you want to make sure that that term has a positive coefficient. So if this were a negative 2x to the 5th, I would have added it on this side and made this side the 0. How many solutions are there to this equation? 5. How do you know?
The degree is
The
5.
degree is 5. Now, they may not all be real, but there's at least one real. And you don't need to know that. You just need to know that there's 5 solutions that may or may not be helpful.
You know this one's real.
Because I know more than you do about polynomials. If it's odd, did we do end behavior yet? We've talked about end behavior? Okay, if it's odd, the end behavior has to be like this, which means you have to cross at least one time to go from here to here. If they're both up, we could have lots of ups and downs above the x-axis, which could mean that there's no real solutions. But if it's odd, it's got to go through at least once. Okay? What do I do first?
Figure out what's common.
Which is
It's a, yeah,
2x, leaving you with x to the 4th.
minus 6 squared plus 8.
And you are now in quadratic form. So you get 2x, you get x squared minus 4, and x squared minus 2 equals 0. Factoring the trinomial, factors of 8 that add up to 6 will be minus 4 and minus 3. Now, because we're asking for real number solutions, the way you find them is to set each of these equal to 0. So if 2x equals 0, what does x equal? 0. If x squared minus 4 equals 0, and you could have factored that to x plus 2x minus 2, but I'm going to just make it be x squared equals 4 and x equals plus or minus 2. And here, x squared minus 2 equals 0, x squared equals 2. What does x equal? Oh, plus or minus root 2. So our solutions are going to be x equals 0, plus or minus 2, and plus or minus root 2. There's 5 solutions. Now, it doesn't matter to me which order you write them, but you also could have factored this, and that would be fine with me also.
Since you're in equation form, do you have to like take the 2 out and put it like beside the equation in parentheses? You can't like divide it by 2.
You can. It doesn't matter to me. It's an equation. If you divide by 2, that's fine. It just seems like extra work.
Okay.
Okay? So here's our 5 solutions. Does someone have a question on why they're these? So when you're solving, you need to factor first and then set each factor equal to 0. What's in common? N to the 3rd. What's left? Equals 0. Then you need to set each factor equal to 0. N cubed equals 0. N plus 6 equals 0. What does n equal here? Rush. 0. And here? Now, whether you write this or not, I don't really care if you use this. This is not necessary for me. This is necessary, and this is necessary. N is equal to 0, 6, no parentheses. And I'm going to start saying these things now because it's going to be important in a day or two. Sorry. 0 is called a triple root because this factor n appears 3 times. In other words, we could have said n times n times n times n plus 6 is equal to 0. So we have 0 as a root, 0 is a root, or a solution, excuse me. 0 is a solution, and negative 6 is a solution. We're going to call this a triple solution. You don't need to worry about it now, but however many times the factor appears, that's what kind of a solution it is. Negative 6 is a single. 0 is a triple. That's going to be super critical for us later. Remember, you need to make sure when you're solving that you're setting it equal to 0. Okay? You set equal to 0. If you're already there, that's great. Okay? And the last one are more of the variables, or where we have a variable in the application. We have a volume of 12 units. Find the dimensions of the tank. This one becomes a real cluster to begin with. How do we find the volume? What should I plug in for volume? Equals Now here's the problem. In order to solve this, what are we supposed to do? What's the first thing you're doing if you're solving? Oh, smokes. What do we say to do when we're solving? No.
One side equals 0.
Get one side equal to 0. That has to be a priority when you're doing this fish tank problem. So you are going to get rid of the parentheses. You are going to multiply the binomials first if you want to keep your life simple. Then what do we do?
Subtract 12.
Do what?
Subtract 12.
Subtract the 12. So we get 0 on the left. And then you're going to do factor by grouping. Finish this off. All of the answers that you get here don't work. You need to check to see which ones work. You have a quiz tomorrow. Homework 28.